Hello guys, welcome back. This is Dr. Hadi here and you are watching the Medical Glow by Dr. Hadi. Today's topic is from Biochemistry, Advanced Level Biochemistry for MBBS, DPT, Physiotherapy, Pharmacy students. The difference between these four words, chylomicrons, VLDL, LDL and HDL. What are these terms? And I would try my best to remove the confusion that exists in the mind of a lot of students. First come to chylomicrons. If you see on the whiteboard, the four words mentioned on the whiteboard, chylomicron, VLDL, LDL and HDL. Why these four words are on the whiteboard? Because these four are similar with each other, they are related with each other, that's why. And you will get your concept clear today. Look, if I draw a diagram here on the whiteboard, from this diagram you will clear the idea regarding these four terms. Actually, four different things they combine together, to give us these structure, LDL, HDL, VLDL and chylomicrons. The very first thing that you should know. What are these four things? TG, PRO, CHO, PL. TG for triglycerides, Pro for protein, especially apolipoprotein. So it's a very special protein that is specially designed to attach lipid with itself. Third is cholesterol, CHO for cholesterol, and the fourth one is phospholipid, PL. So these four things, when they combine together, they will make a ball-like, more or less ball-like structure that is called chylomicron, VLDL, HDL or LDL whatsoever. So this diagram is a perfect diagram for you to understand what is chylomicron, VLDL and LDL. These are just ball-like structure, and you can see all the four individual components here. Okay. Now, what makes these different terms available to us? How we judge the four different terms from this one diagram? Actually, it is the quantity of triglycerides and cholesterol that vary from one structure to other, that vary between the different structures. For example, if you see HDL, high density lipoprotein, here in high density lipoprotein, the protein is 40% and cholesterol is 25%. So in this structure, if the cholesterol is 25% and protein is 40%, so this structure is HDL. And if here protein is less 20% but cholesterol is high 50%, then this structure is called LDL. So as I told you in the beginning, that this structure actually represents all these four terms. So what thing decide is the amount of the individual substituent. This is first thing. Second, the formation. In case of HDL, the ball-like structure is formed in intestine as well as liver. Both intestine and liver can be formed. But in case of the LDL and VLDL, these two, that ball-like structure can be formed in the liver, secrete from the liver only, In case of chylomicrons, which is the same structure, chylomicron is secreted from the intestine only. So this is second. First difference was the structural difference. Second difference was in the secretion, the place where these are secreted. And now third, the main function of all these four balls, all these four structure is to regulate the lipid fats level in our body. To regulate fats level in our body. You know, we take fats and lipids from outside in the diet, and when it reaches to our intestine, then there must be some mechanism to take these fats to the target site. So individually lipids cannot travel in the blood, because it is the blood that should take the fats from the intestine from one place to another. It is the blood, you know, it is the blood that takes the fats from one place to different parts of the body. So as such, lipids cannot travel, but lipid require a special structure in which the lipid encloses itself, and then the structure can carry it. That's why I call them the carry balls, like carry dibba, carry people from one station to other. So carry balls, they carry lipid from one place to other. This is very simply, if I say very simply. These structures are involved in the metabolism of lipids. Now I would like to tell you how. First, start with the chylomicrons. In chylomicron, if you see here, phospholipids is there, and you will also find a lot of triglycerides. Okay, triglycerides, suppose this structure represents triglycerides, 90% triglycerides. So chylomicron can be identified from the quantity of triglyceride. A very high amount of triglyceride is there in the chylomicrons. However, the remaining two substituents, that is cholesterol A and cholesterol and apolipoprotein. This is apolipoprotein, fine. Apolipoprotein, very less. Cholesterol is also very less. Cholesterol is there, apolipoprotein is there. All four different substances are there, but they are very less. So I have mentioned protein, very less, cholesterol very less, phospholipid very less, but triglyceride is much, in excess 90%. One thing more, the protein which we call apolipoprotein, present here in chylomicron, has got its own name. That is apolipoprotein A48. This is just the name that you have to memorize. Apolipoprotein A48 is the protein that is present in chylomicrons. But if you come to the VLDL, where triglyceride is there, just like chylomicrons, it is also 80% or 90%, roundabout, much more. Protein is less, cholesterol is less, phosphate is less. So it looks like VLDL and chylomicrons are similar, but no, these two are not similar. These are different, because the protein in the VLDL is B100 here, this one, B100. It is A48, but here it is B100. So the protein is different in case of VLDL. Okay. Come to the function of chylomicrons. Chylomicrons start from its journey from the intestine. When it's secreted from the intestine, it enters your blood. So when it enters your blood, it will distribute the triglycerides, usually that it has taken from the intestine, whether it is triglycerides or vitamins whatsoever. So some of vitamins are fat soluble vitamins, so maybe it's a fat soluble vitamin or just triglycerides, fats they take from the intestine and carry in the blood. In the blood, they will search a specific target site, like fatty tissue, means where in our body we have fatty tissues. So the extra lipids will be stored in that fatty tissues. So here is a diagram of tissue. Here in tissue, fatty tissue, the fats will be deposited, means carry in the blood and take it outside of the blood and deposit it into the tissue. So this is the first task. Or the lipids, or you can say the vitamins, fat soluble vitamins, can be taken from the blood into the liver. So this is also the task of what? Chylomicrons. Because we have started a vitamins chapter, and tomorrow or day after tomorrow we will discuss vitamin A. So vitamin A, you will see that vitamin A will come from the intestine, it will enter into the blood, and from the blood it will go to the different sites, including the liver. So there you will see the word chylomicron. So you got chylomicron. What is chylomicron here? So this is all the task of chylomicrons. It deposits fats in the fatty tissue, and if it has taken some fat soluble vitamins, the fat soluble vitamin will be delivered to the liver. So overall chylomicron's function is to carry fats, triglycerides or fat soluble vitamins from one place to another. Finished. Now VLDL. VLDL does not take its journey from intestine. VLDL is synthesized in the liver. Specifically, it is synthesized in the liver. Liver has the capability to synthesize all the 4 components. Means liver can synthesize triglycerides, protein, cholesterol, phosphorus. All this can be available in your liver. So these 4 can be combined, and as a result you can see that liver has synthesized VLDL, very low density lipoprotein. Why the word very low density lipoprotein? Because here protein is very less. Very low density means protein is very less. So don't think that it is the fats that fat is very high. The fat is very less. In fact, fat is very high in VLDL. Fat is very high, especially triglycerides. Okay, I have already mentioned that triglyceride is very much here. Protein, cholesterol, these are very less. What is the function of VLDL now? VLDL. Its function is quite different from chylomicrons. Its function is it delivers triglycerides while circulating in the blood. Means it has started journey from the liver, and it will collect the triglycerides and distribute into the various body tissues. Our body require triglycerides. So wherever body require triglyceride, it will just deposit it. Okay, please take this triglyceride. Take this triglyceride and take. So this will be the diagram that in different body tissues, this is our body tissues. So VLDL will transfer triglycerides from blood. So this diagram represent what? This diagram represent blood. This is blood vessel. Okay, this is what? This is blood vessel. So in the blood, it will deposit here some triglycerides, here and here. So it will just deposit. What will happen as a result of this? The quantity of triglyceride in VLDL will be decreased. Why? Because it is distributing it. So its size will also decrease. Size is large, but size will become smaller and smaller. So when its size becomes smaller and smaller, sufficient enough that the triglyceride level is very decreased, then you can call it LDL, low density lipoprotein. Low density lipoprotein. This is very low, and this is just low density lipoprotein. Now we saw this VLDL. Okay, just deliver fats to the where required, because our body requires fats. So it has done its job. Now this is very much important. If I say these 2 are very much important regarding especially the cardiovascular disease. LDL has very less triglyceride. This is very clear. Okay, fine. Triglyceride is very less. Protein is little bit high, 20%. Protein, apolipoprotein is there. Okay, 20% is there. This is most important thing is the cholesterol. Cholesterol, among all these 4 different forms, none of the form has very high quantity of cholesterol. But this form, LDL, this form of LDL, has a very high cholesterol, and there is a purpose behind this, why this high amount of cholesterol is there. 50% cholesterol shows that this LDL will deposit cholesterol in the body where it is required. For example, this form of the cholesterol will start circulating in the blood, and wherever cholesterol is required, it will just transfer the cholesterol and deliver it to that part of the body. For example, your cell membrane require cholesterol, so cholesterol will be given. your kidney, adrenal gland require cholesterol. So LDL will provide the cholesterol to the kidney, especially the adrenal gland. Why? Adrenal gland will synthesize hormones like glucocorticoids, mineralocorticoids. These are all cholesterol based hormones. So hormones will be synthesized. So in this aspect, LDL is good because it help us synthesizing hormones in our body. But it can be dangerous sometimes if the quantity of LDL is very high in the blood. It is not bad up to a limit, but when its quantity is increased from that limit, then it is very dangerous. How? It has very high amount of cholesterol, so this cholesterol cannot be deposited in the body tissues now. As a result, this cholesterol can be deposited in the blood vessel because it's very high. If you consider a truck of garbage that carry garbage using a road from one place to other, if the garbage is very less in that truck, so garbage will not fall on the road. In case the truck is full of the garbage, so most of the shoppers garbage, they will fall on the road, and as a result road shape can be badly affected. So this one can also lead to a very bad condition like deposition of the cholesterol in the blood. So this is your blood vessel. In the blood vessel, the cholesterol deposit here and a little bit cholesterol deposit here. This cholesterol deposit will make a clot. As a result, the lumen of the blood vessel will be narrow, means now it is very narrow, the blood cannot pass here very easily. So this condition may lead to the cardiovascular disease, heart attack, and so many other other disease. So that is why LDL is very bad. When you take your test, when you take a lipid profile test, in that test we see that LDL is high or low. If the LDL is low, it is good sign. If the LDL is high, it is a bad sign. Okay, so now what is HDL? HDL has the similar structure, means triglyceride is there, protein is there, cholesterol is there, and phospholipid is there. But in this case, the protein is very high. 40% protein is there. There is also a purpose behind this. There is also a purpose behind this because this structure is a very friendly form. This structure actually prevent our body from the bad effect of the LDL. This structure actually starts circulating in the blood. It moves from one place to another place, and it just check whether there is some extra cholesterol is there or not. If some extra cholesterol is present in our blood, extra fat is there, let's suppose, it will just catch this extra lipid, extra cholesterol, and take it to the liver. So let's suppose this is our liver. Fine, this is our liver. So it will take this is your structure HDL. There are some extra cholesterol. Okay, so let's suppose this color represents cholesterol. So cholesterol will be taken from the circulation, blood circulation. So now there is no cholesterol in our blood. So these cholesterol will be then carried to the liver, and liver will store it or metabolize it or do something else with this cholesterol. So as a result, the blood is now free of the cholesterol. That is why it is called good cholesterol, because we don't want very high amount of cholesterol in blood. However, we need little amount of cholesterol for our body need, but extra cholesterol is dangerous. So how this is prevented? By the help of HDL. HDL will take extra cholesterol from the circulation and deposit it in the liver. So this is very good for to protect the effects, the bad effects of LDL. I hope you got this idea from chylomicrons, VLDL, LDL and HDL all in one lecture. In the next video lecture, we will come to the vitamin A description inshallah in detail. So take care and bye bye.